So there is some bad news about Hamilton paths and Hamilton circuits. You might remember, I hope you remember from 14.2 that we were doing Euler circuits and Euler paths. And there was a nice theorem that told us whether or not a connected graph had an Euler path or an Euler circuit. The bad news is that we do not have a theorem to tell us about Hamilton paths and Hamilton circuits. So there's the bad news. There is no theorem to tell us whether or not a graph has a Hamilton path or a Hamilton circuit. Mathematicians have studied this for a long time, and they've kind of come to the conclusion that this type of thing, looking for such a theorem, is something that will never happen. That they cannot put their finger on this. One of the things about this class is for you to kind of realize there are some math problems that are not solved. People are surprised about that. People who, have taken math in high school and whatever they've taken in college are thinking, math is all figured out already, but it's not. Anyway, this is one of those problems that's kind of out there, so you just kind of have to play around with the graph and see if you find one. That sounds like we're on shaky ground. So I'm going to write that. We kind of just have to use trial and error to see if we find a Hamilton path or a Hamilton circuit. And somewhat, just because you didn't find one, doesn't mean the person next to you might not find one. So it does sound like we're on shaky ground a little bit. But there is some good news. The good news is that mathematicians have studied this enough to know there are certain kinds of graphs that will always have Hamilton path or Hamilton circuit. So let's write the good news. There are certain types of graphs that always have Hamilton paths or maybe Hamilton circuits. So while you might have been kind of sitting there in almost a panic mode when I said, but we really don't know a surefire way to find them, the good news is there are certain types that always have it, and we're going to study one of those types in this class. So the type that will always have it is called, and we're looking Hamilton circuits. A complete graph will always have Hamilton circuits. So I need to give you a definition of a complete graph, but let's write that. A complete graph will always have Hamilton circuits. So a lot of the questions in the homework deal with complete graphs. So what is a complete graph? I'll give you the definition for that. Complete graph is a graph where we have an edge between any two vertices. So pretty much you can pick out two vertices. Anywhere on the graph, there's an edge between them. If you think about airports, pick 5 airports, there's a direct flight between any two of the airports. No layovers.